Welcome to Chapter 7, Modeling New Waves. So we've just begun a new part of the course and opened up notebook number 7. This is part 1, Limit the Data. So thus far we've only looked at one wave at a time from each area. It's possible that there are multiple waves in each area, and so we need to figure out how to handle those multiple waves. Let's look at a concrete example from Australia. We're just going to go ahead and input our general logistic function. And we're going to get the data from Australia. And we can see there are two very clear waves here. So one that begins in March and ends somewhere in April. And there's another that begins somewhere in July and ends in September. So let's go ahead and try to model both of these waves at once using our current generalized logistic model. So we're going to go from the beginning, so from February all the way to August 1st. That's going to be our input. And we're going to use the same parameter ranges that we did before. We will use a fairly high number for the asymptote on the right, so we don't know where it's going to end up after August 1st. And so here is the predicted, this orange line, and it does not look, it is going up. Well, they always go up. This is the property of our function, but it doesn't seem to follow the trajectory whatsoever. So one solution here is simply to just limit the amount of data that we see. So I just put 50 days, but this is just limit to last, say, n number of days. So we just forget about the past. So it may not even really be necessary to know anything about this particular wave, since this one is sort of independent of that one. So we can look at this one by itself and just build a model for that wave. So let's go ahead and do that. And we'll select a start date from June 1st, so right here, so clearly separate from the first wave and right before the second wave begins. Here's that data right there. And then we can use our predict all and build a model like that. And we can see that, oh, well, it actually does not seem to really fit all that well. That it is obviously going up, but it's not conforming to the normal trajectory shape. So there's an issue here, and we are going to talk about that in the next video. But the first step is simply to limit the data, and then we'll figure out how to make this work with our general logistic